So if I want to evaluate the average value of a function over an interval, so say from a to b, it's simply the definite integral of our function from a to b, so just the definite integral from a to b, and then we'll divide that by the length of our interval, 1 over b minus a. So we'll in this case, you can think about it as dividing by b over a, so we could write this as the definite integral from a to b of f of x dx all divided by b minus a, but I think that's too much. I always prefer to multiply here, so we'll just multiply by the reciprocal. We'll multiply by 1 over b minus a. So here I want to find the average value of f of x equals 6x squared minus 2x over the interval -2 to 3. So here this is hopefully should feel like a relatively straightforward application of this formula here. So 1 over b minus a, this will be 1 over 3 minus -2 times the definite integral from -2 to 3 of our function f of x, that is 6x squared minus 2x, minus 2x dx. So I'm just trying to evaluate this definite integral, and then at the end of this, I'll multiply it by 1/5. So here, 1 over 3 minus -2, that is 1/5. Here I need to find my antiderivative, so let's see, I will have, what will I have there? 3, nope. Let's see, 6x cubed, 2x to the third, there we go, minus x squared, evaluated at 3 and -2. It's up to you whether you want to multiply this 1/5. You could actually distribute it here if you really wanted to. You could multiply both terms, the f of 3 and the f of -2 by 1/5, or you could just multiply the result by 1/5. It's up to you. I'm going to leave this out. I'm going to say here's 1/5, and I'm going to start by evaluating this at 3. So this will be 2 times 3 to the third minus 3 squared minus 2 times -2 to the third power minus -2 squared. And I'm just trying to evaluate this result. So 1/5 times, let's see, 3 to the third would be 27 times 2. I should have 54 minus 3 squared would be 9. Minus over here, -2 to the third power would be a -8 times 2 would be a -16 minus -2 squared. That's going to be minus a +4. So let's see, I have 1/5 times 54 minus 9. That should give me 45. Minus over here is -16 minus 4. That would be minus -20. So here I have 1/5. Oops, and I'm kind of running out of room here. I end up with 1/5 times 65, which should be 13. So for the most part, if you know this formula, it's a relatively straightforward process. You're just going to do the definite integral from a to b and then just multiply the result by 1/5. Notice I really didn't do a whole lot with this 1/5. I just kind of brought it along for the ride until the very last step when I went ahead and multiplied the result of my definite integral by 1/5. Last thing, I just want to draw a distinction between average cost and average value. So here we have an example. It says the total cost of producing X dictionaries is given by C of X equals 20,000 plus 10X. Part A says find the average cost if 1,000 dictionaries are produced, and here we're given the hint, use C bar of X. This is something that we haven't seen in a while. It's probably good since we have a final exam coming up. If I want to find the average cost is given by C bar of X, which is C of X divided by X. So you could, if you wanted to, take 20,000 plus 10x over x. We could simplify that and say 20,000 over x plus 10 if you really wanted to, or you could just leave it like this. It's up to you. But I want to evaluate this if 1,000 dictionaries are produced, so I want C bar of 1,000. So here I'll have 20,000 plus 10 times 1,000 divided by 1,000. Oh, and here let me grab my graphing calculator. 20,000 plus 10 times 1,000 be 30,000 divided by 1,000. Here I have an average cost of $30 per dictionary. So there is my average cost, and I want to contrast that with the average value of the cost function over the interval 0 to 1,000. So here we're talking about the average value. We want to use 1 over b minus a times the definite integral from a to b of our cost function c of x dx. Excuse me. So I'm just using the average value function that we gave earlier. So let's see. We want 1 over 1,000 minus 0 times the definite integral from 0 to 1,000. C of x. What was c of x here? We said that was 20,000 plus 10x dx. So this is 1 over 1,000. Let's see our antiderivative. That will be 20,000 x plus 5x squared, evaluated at 1,000 and at 0. So I have 1 over 1,000 times, here I'll have 20,000 times 1,000 plus 5 times 1,000 squared minus 20,000 times 0 plus 5 times 0 squared. So first of all, 20,000 times 0, this is going to be 0. 5 times 0 squared, that's going to be 0. We don't need to worry about that part over there. So I have 1 over 1,000 times, let's see, 20,000 times 1,000 plus 5 times 1,000 squared. Take that result, divided by 1,000. I have what looks like, here, let's just jump to the results. I should end up with $205,000. So this is the average value of the cost function over 0 to 1,000. Notice that this number is really, really different than our average cost. So make sure that you're paying attention in this section. We want to make sure that we don't mix up average cost or average revenue or average profit with average value. They both have that word average in it, but the process that we use to find them is very, very different.